Dr. Pielke, and I'll recognize myself for questions, and let me address my first question to Dr. Curry. And Dr. Curry, let me say at the outset, I know you could take an hour to answer this question. Unfortunately, you'll have to give me a summary. And the question is this: what are the uncertainties, complexities, biases involved with climate science, or the study of climate science, that need to be considered before we can actually make informed decisions about what to do about climate science?
Well, the greatest uncertainties in both our understanding and our ability to model the climate system relate to these items. The first is what I call the thermodynamic feedbacks related to clouds and water vapor. Climate models have a large amplifying effect from clouds and water vapor. The magnitude of this amplifying effect and even the sign are in dispute. A lot about the oceans that we don't understand, how the ocean transports heat and carbon in the vertical is not well represented in the climate models. We also have these very large-scale, long-term ocean oscillations, which play a huge role in determining our climate. These are not well simulated, and we don't have good documentation of the really long time period oscillations. The effects of the sun on climate, particularly the indirect solar effects. And I could go on, but I think those are the key issues.
And you didn't even get into the biases and other uncertainties, but that's a good start, and that gives us an idea. Thank you, Dr. Curry. Dr. Christy, the PowerPoints you put up on the flat screens a while ago, I thought were absolutely riveting and, at least to me, very persuasive. My question is, why are both the satellite and surface temperature measurements so far below the climate model predictions? In other words, there's a conflict between the data and the predictions. Why is that?
Well, there are a lot of answers, I suppose. I can speculate about some. What we've seen is that the models tend to be too sensitive to greenhouse gases, likely related to the fact the models tend to shrink clouds more than in reality, so that more sunlight gets in and heats up the Earth more. So that's one idea that may be the reason, but overall the basic answer is the models are too sensitive to extra greenhouse gases. The Earth has a way to release the heat that greenhouse gases try to build up.
I think most instructive was the line that showed the actual observations as opposed to the modeling, and how big of a discrepancy there was between the two. Thank you for pointing that out. Dr. Pielke, you, in your testimony today, mentioned that extreme weather events are not necessarily caused by climate change. In fact, the IPCC has said there's low confidence that there's any connection between climate change and extreme weather events. Why are some climate scientists claiming that there's a connection when you and other scientists in the IPCC all says there's likely not a connection?
Yeah, when you talk about trends and extreme events, it's really important to focus on the phenomena. You're talking about hurricanes, floods, drought, and look at those individually. It's long been a puzzle to me why there would be any controversy over this topic, since something like a hurricane is pretty big. It's easy to see when it occurs. We have very good data on it. In the United States, a number of hurricanes and the intensity of hurricanes is down by 20% since 1900. I don't put a lot of stock into that because you can start at different dates and get different trends, but the point is there's no evidence to suggest that hurricanes, either in the U.S. or globally, are increasing, and the same goes for floods, drought, and tornado. And don't believe me, you can look at the appendix that I provided with data from the IPCC. So why people would hang their hat on long-term trends in extreme weather is a puzzle.
Okay, thank you, Dr. Pielke. That concludes my questions, and the gentlewoman from Texas, the ranking member, is recognized for hers.